Okay. Okay. You see my screen okay?
Yeah.
All right. So your first question is, whoops, let cosine. All right, let's do each one of these things on its own. Let's see if we have enough room for these. Let f of x equal the cosine of 2x minus 6x. Show that f has a differentiable inverse. Yikes. Differentiable inverse. It's the first time I've seen this kind of question. So do they first do you first have to make the inverse, create the inverse?
I think so, yeah.
Is that what they want you to do?
Yeah.
Man, this is Calc AB.
Yeah.
Holy cow. I don't remember seeing this kind of stuff. So let's see if we can find an inverse. You remember how you make inverses is you interchange the x's and the y's. So this would be cosine 2y minus 6y.
Okay.
But I don't really know how to get those y, how to isolate the y when you have one inside a cosine and one outside. Have you done anything similar to this in the class?
No.
Let me see. I think maybe you don't have to show f has a differentiable inverse. I think there must be a different way to do it besides. Okay, so this is what I found. It's the inverse function theorem. Have you learned this yet?
Maybe.
This is kind of new to me, or at least I haven't seen it in a while. It says let A be an open interval and let f be a function, be injective and differentiable if, I'm not sure what injective means. If the derivative does not equal 0 for every x in A, then f inverse is differentiable on f of A, and f inverse equals 1 over teeth. So you telling me you haven't gotten anything? You haven't seen any, you don't have any notes on this?
I have notes on like the inverses of like cosine, sine, tangent, secant, cotangent, cosecant.
Right. And you're sure that this is how this formula is written out? Cosine of 2x minus 6x, and 6x is on the outside?
Yeah.
Okay. And you're telling me you don't have any notes that talk about this?
No.
I have a hard time believing that you wouldn't have something. Did she want you like look it up in a book or something?
I'm not sure. That's why I was confused. We can just skip this one and I'll figure it out later. I can ask her in the morning.
Yeah. Let's come back to this when we have time, okay? Because that I'm gonna have to look that one up. And I'm looking it up right now on another computer, but I'm not. It's a lot for me to look at. There's got to be another way to do it besides finding the inverse of the function and then finding the derivative of that. There has to be another property that she wants you to use.
Okay.
So for page 2, we're saying that find dy dx if y equals x to the, all right, this one is this what the function is? X to the 1 minus e?
Yeah.
Okay. Well, 1 minus e is just a 1 minus e is just a number. It's not a variable, right? This is just a number up here. You understand? Because e is just like 2.7 something.
Okay.
So really, it's just like find the inverse of x to a power. And how do you find the inverse if you're raising x to a power? Do you
Isn't
remember
it
what you do?
is that the a to the u is like a to the u times ln a times u?
No, it's much simpler than that. All you have to do, if I told you that y equals x to the fifth, what would the derivative of y be?
5x to the fourth.
Yeah, it's just the power rule.
Okay.
And that's really all we have here. This is, like I said, this is just a number. So what do? I take this number and I bring it down to the front, right?
Okay.
So it's 1 minus e, and then it's x to what power now? It's 1 minus e, and what did I do? How did I do this over here?
Minus 1.
Yeah, you just subtract 1 from it. So that just equals 1 minus e in front times x to the, now these ones cancel out, negative e. That's your answer. That makes sense?
Yeah.
That one was only, the reason that one was tricky because of the way it looked. All right, so for this one, they want us to find dy dx. Okay, so this is going to be where we're going to have to use that chain rule. Is this called implicit differentiation, what we're doing here? When you've got y's and x's?
Yeah.
Does that name sound familiar?
Mm-hmm.
So we're gonna, let's see if we can simplify this at all first before we start taking the derivative. I'm gonna write it over here. X sine of xy equals x squared plus 1. Not really much I can do to simplify that, right? I mean, I guess I could, well, you know what I could? I could divide both sides by x. Couldn't I?
Mm-hmm.
Just to make it a little bit simpler, because then it would be x plus 1 over x.
Mm-hmm.
You understand?
Yeah.
So now when I take the derivative of both sides with respect to x, what's the derivative of sine?
Cosine.
So this is going to be cosine, and then you leave the inside unchanged, and then you multiply it by the derivative of the inside, right?
Mm-hmm.
Follow what I'm doing here?
Yeah.
And what's the derivative of x times y? That's a power rule, right?
Yeah.
It's the first one times the derivative of the second plus the second times the derivative of the first, which is just 1. Follow how I did that? Or do I have to show you what I did? Follow it?
Yeah.
Okay. And what's the derivative of x?
1.
And what's the derivative of 1 over x? Remember, that's like x to the negative 1.
X.
So the derivative of this would be negative 1 times x to the negative 2, which is just negative 1 over x squared.
Okay.
Got it?
Mm-hmm.
So there's my work. So I'm going to write it here. Minus 1 over x squared. All right, now we got to do a little bit of algebra here. Actually, this isn't too bad because notice that I really only have one dy dx. So I just need to carefully move everything to the other side.
Mm-hmm.
So first step, let's get rid of this. How do I get rid of this?
Divided from that side.
Mm-hmm. Yep. So divide it, and I'm just going to divide it to each term.
Mm-hmm.
just because it'll look a little bit nicer if I do it this way.
Mm-hmm.
Okay, got that? And that
Yeah.
equals x times dy over dx plus y. Now what?
Subtract y.
Mm-hmm.
From
So you'll get, I really don't have to show you all this, but I will. Dy over dx equals, you know what? I'm not going to show it all to you. I'm just going to do it with color coding. There's negative y. And then how do I get rid of the x?
Divide both sides by x.
And that's right. So to get rid of this x, I'm just going to put it in the bottom of all of these things.
Mm-hmm.
So there's my answer. Dy dx equals 1 over x cosine xy minus 1 over x cubed cosine xy minus y over x. Now, you could write this as one big fraction, but I don't know if your teacher wants you to do that. Getting common denominators, you know?
Yeah, I think the answer on here is all together.
Okay, so if we want to put it all together, we would have to get common denominators. So this would have to be multiplied by x squared here, so that you would get an x cubed on the bottom, right? And this over to the right would have to be multiplied by x squared and cosine xy. So you have x cubed cosine xy on the bottom. So your answer would be now dy dx equals, so now I can write everything together in the top. It's x squared. I'll put the x squared y first because it's more complicated. Negative x squared y cosine xy plus x squared minus 1 all over x cubed cosine of xy. Is that the answer your teacher had?
Yeah, I think so.
Okay, see how that worked?
Mm-hmm.
Any questions on that? Were you able to follow that okay?
Yeah.
And again, you can go back and watch that video if you want. That'll help.
Okay.
All right, so do you have another question similar to this with implicit differentiation? That I can do.
I did the other one and I understand that one.
Okay, so let's go. But you want to go back to number 1 now? We should have plenty of time to do it. I'm just trying to figure out what they wanted you to do.
Mm-hmm.
Do you have the answer key for this one?
Yeah.
Maybe, you know what? Maybe paste it and I can work backward to explain it to you. Let's try it like that.
Okay. This is what she had in the answer key.
Sorry, Maggie. I think I lost you there for a second. I don't know what happened. Can you hear me now?
Yeah.
Okay. Did you get booted off of Zoom or just me?
I think it was just you.
Wow. How did that happen? Wasn't I the one hosting it? I actually, I was taking my jacket off and my AirPods fell out, so that's somehow how it happened. Okay, so you're saying that she's giving you, I don't, by the way, we may not be live anymore. I'm not sure, probably canceled that as well, but that's okay. This is the answer key.
Yeah, that's what she had.
Well, that's not very helpful. You don't have any notes for it?
No.
Okay, here's what I'm reading on Stack Exchange. Suppose we have a differentiable function g that maps from a real interval I to the real numbers, and suppose that the derivative is greater than 0 for all r in I. Then I want to show that g inverse is differentiable on g of I. This seems way too complicated. Intuitively, it makes sense, but I can't come up with a neat proof. I was thinking use the mean value theorem. Yeah, you're not going to do that. Okay. It's got to be a simpler thing.
Yeah.
Oh, wait, here's one. Quizlet. Let f of x equal cosine x plus 3x. Show that f has a differentiable, probably it's going to say inverse. But it's a Quizlet. That's weird. And it's making me log in to view it. And what are you doing? I completely lost that. It actually looked like that might have been helpful, but I lost it. For some reason it wouldn't, doesn't have me logged in. Show f has a differentiable inverse. Yeah, somehow it's a Quizlet thing. Oh, it wants me to create free accounts to show. I already have a free account. Apparently not. Apparently I don't have one with.
I can just ask her about it tomorrow morning.
Okay, hold on one second. I have a Quizlet account. Okay, got it. Hold on, give me a second. So step one, okay, hold on. The derivative, okay, so here's the steps that I see in Quizlet. So the first step, it looks like, is to take the derivative of f of x. So the derivative of f of x is 2 sine 2x minus 6, right?
Mm-hmm.
The minimum value f that the derivative can have is when sine of x equals, I'm looking at a different one, and so the first derivative is positive for all. Yeah, so there's a whole process that they want you to do here. So you first take the derivative, you show that okay, so here's what I don't know if this is going to make sense to you, but I'm reading what it says on Quizlet Plus. So the equation that they had, it's very similar. It was cosine of x plus 3x. So what they did is they took the derivative of that, which is negative sine of x plus 3. And then their step to show that it has a differentiable inverse was to show that the minimum value, the min value of f of the derivative that it can have is when the sine of x equals 1 and the derivative is 2. So what's the minimum value this can have here for us? the minimum value this can have is where, see, the smallest that this can be, sine is never less than 1. So it's when this equals -1 is when that's going to be the smallest value. Does this sound familiar to you?
I think so.
So when the sine of 2x equals -1, that'll be the min of f prime of x, of the derivative.
Okay.
So do you remember how to solve that?
No.
Well, we can, I don't know that we have to do that. So that means that the minimum will be that f prime, or f, yeah, the derivative could be, the minimum of the derivative is going to be -8, because this could be -1, no lower than -1. So this whole thing can't be any smaller than -8.
Okay.
That makes sense?
Yeah.
So the first derivative is positive for all x. Okay, so here's what they're saying for this one down here. So they're saying because the min value for this is 2, they're saying the min value for that is 2, and that's when sine of x equals 1. They're saying that the first derivative is positive for all x. Therefore, f of x is increasing everywhere and is strictly monotonic. Oh, that's what they're doing. Huh. Okay. It doesn't really relate to ours, though. So what they're basically proving, what they're showing is that this right here, they're doing like kind of like graphical analysis with it. Does this sound familiar to you? And they're saying that this is strictly monotonic, meaning 1-to-1, meaning as long as it's 1-to-1, then its inverse is also a function.
Okay.
So the derivative is positive for all x, and therefore f of x is increasing everywhere and is strictly monotonic. I don't get the reasoning behind that. And then they're showing that they're saying f of x is differentiable everywhere, and that the derivative doesn't equal 0. Yeah, see how this derivative can't equal 0? The derivative here, I'm looking at the one that they have on Quizlet. The derivative can't equal 0, and therefore that implies that the inverse is differentiable everywhere.
Okay.
Because you can't have a problem. Yeah, I feel like I don't know if this is how they want you to do it. It's just surprising to me that you haven't done that. You don't have notes on this and you haven't done that before.
Yeah.
Because it's kind of complicated. Now these things we can do, B and C. Here's the derivative. Just plug it in, right? Plug 0 in.
Mm-hmm.
So f of 0 would be the cosine of 0. You know how to find that, right? Cosine of 0 is 1.
Mm-hmm.
So 1, so that's why this equals 1. And the derivative, I'm sorry, yeah, the derivative is here. The sine is 0, so shouldn't this be -6?
Mm-hmm.
Oh, it is -6. Got it?
Yeah.
And the inverse, see, this is where I'd like to see, how do they find the inverse? I think what they're doing here is they're flipping. They're somehow relating these. That's what I'm saying. There's something that we're missing, some notes that we're missing.
Okay.
but I'm so sorry, I don't know what they are. That you're the first person that's ever asked a question like this to me, ever. Who's your teacher again?
Mrs. Liakis.
Oh, I've tutored her students all the time before. Yeah, why don't you maybe send that to me once you find the notes on this?
Okay.
How are you at taking notes in class? Do you get the notes done pretty well?
Yeah.
But you never saw notes on finding out how if an inverse is differentiable?
Yeah, no, that's why I was confused.
I wonder if maybe she just hasn't done it yet. Is this like the only problem you had?
Yeah, that's like the only one in the packet that I haven't done.
So maybe she just hasn't gotten to it yet, you think?
Yeah, that might be it.
I feel like there's a simple explanation for this. I just can't find it with a quick internet search. So I'm so sorry.
That's okay. Thank you.
All right, I'll see you. Talk to you later.
Bye.
Bye-bye. Hi, Achind, how are you?
I'm good.
Good. Am I sharing my screen with you or no?
No.
Am I sharing it? No.
Yeah.
All right. How did your day go today in school?
It was okay. Long, but
Do you feel like you're getting the hang of this stuff any better?
yeah, we had a review period in math. So I added also some other questions to the Jamboard I shared with you yesterday. And then I ran out of slides on that one. So
Okay, so which one do you want me to start with?
the one I shared yesterday, please.
The one titled Math Tutoring Help?
Yeah.
And what page are we on?
I think
6?
Excuse me.
God bless you. Okay. So it looks like you have a lot. Do you have an hour with me today? I forget.
Yeah.
Okay, good. So do you want me to record this as well?
That would be helpful, yeah.
Okay. So I am going to change your, oh no, you did already. Good job. Your name is just your first name, which is good. I'm going to, what do you want me to call this?